Good morning students. Welcome to Tata Chem DAV Public School Mithapur online classes. Myself Kavita Modi. Today we are going to continue chapter 2 factors and multiples. In this chapter our topics are finding LCM by listing their multiples, finding LCM by prime factorization method, finding LCM by common division method and some examples. Our first topic is finding LCM by listing their multiples. What is LCM? Let us learn about the least common multiples, or you can call it LCM too. First, let us recall the meaning of the term common multiple. When two or more numbers have the same numbers as their multiples, those multiples are said to be common multiples. Now let us see what do you mean by the least common multiple. The least common multiple of two or more numbers is the smallest number that is a multiple of those numbers. To understand it in a better way, let us solve one example. Find the LCM of 4, 5 and 2 by listing their multiples. First, we will write solution. Everyone know the table of 4, 5 and 2. So the multiples of 4 is equal to 4, 8, 12, 16, 20, 24, 28, 32, 36, 40 and so on. Then we write multiples of 5. So the multiples of 5 is equal to 5, 10, 15, 20, 25, 30, 35, 40, 45, 50 and so on. Then we write the multiples of 2. So the multiples of 2 is equal to 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 and so on. Then we find the common multiples. So the common multiples of 4, 5 and 2 is equal to 20 and 40. Then we find the least common multiple. So the LCM of 4, 5 and 2 is equal to 20. Our next topic is finding LCM by prime factorization method. In this method, you have to remember some important points. Number 1. We start dividing the smallest possible prime number and keep on doing the same till we get 1. Number 2. A prime factorization will contain no composite number. Number 3. Every number in a prime factorization is a prime number. Number 4. There is only one set of prime factors for any number. Let us find the LCM of 16, 12 and 18 by prime factorization method. Write the solution. First we will find out the prime factors of 16, 12 and 18. Everyone knows how we will find the prime factors. So the prime factors of 16 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 2. Then we find the prime factors of 12. So the prime factors of 12 is equal to 2 multiplied by 2 multiplied by 3. Then we find the prime factors of 18. So the prime factors of 18 is equal to 2 multiplied by 3 multiplied by 3. Then we find the LCM. So the LCM of 16, 12 and 18 is equal to, first see what are the different prime factors present in 16, 12 and 18. We see 2 and 3. So make a table like this with 2 and 3. Now fill this. How many times is 2 present in 16? 4 times. So write 4 here. How many times is 3 present in 16? 3 is not present in 16. So write 0. Now if we look to the factors of 12, how many times is 2 present in 12? 2 times. So write 2. How many times is 3 present in 12? Yes, just once. So write 1. Now let's look at the factors of 18. How many times is 2 present in 18? Yes, 1 time. And how many times is 3 present in 18? Count 2 times. Now what we need to do with this? We need to take the maximum count of each prime factor. So first I take 2. 2 is present 4 times in 16, 2 times in 12 and 1 time in 18. So take the maximum, that is 4. So write 2 4 times. Now next is 3. 3 is present 0 time in 16, 1 time in 12 and 2 times in 18. So take the maximum, that is 2. So write 3 2 times. So the LCM of 16, 12 and 18 is equal to 2 multiply by 2 multiply by 2 multiply by 2 multiply by 3 multiply by 3. Do the multiplication and the answer is 144. Our next topic is finding LCM by common division method. You have to remember some points while solving the LCM. Number 1. Write numbers in a line separated by commas. Number 2. Divide the numbers by the least prime number of one or more numbers and repeat the same process of division. Number 3. If the number is not divisible by prime number, then we write that number as it is, and for other numbers we write down their quotients. Number 4. We continue to divide by the least prime numbers till we get all the quotients as 1. Let's start question number 1. Find the LCM of 12, 15 and 45 by common division method. Write 12, 15 and 45 in a line separated by commas. See, 12 is an even number, so it is divisible by the smallest prime number 2. So write 2 to the left of the line and divide. We get 6. So write 6 below 12, but 15 and 45 is not divisible by 2. So write 15 and 45 as it is. Again, 6 is an even number, so it is divisible by the smallest prime number 2. So write 2 to the left of the line and divide. We get 3. See, 3, 15 and 45 all are odd numbers. So it is divisible by the next odd prime number 3. So write 3 to the left of line and divide. 3 1s are 3, 3 5s are 15 and 3 15s are 45. Again, 5 and 15 are an odd numbers. So divide the numbers by smallest prime number 3. But 5 is not divisible by 3, so write 5 as it is. And divide 15. 3 5s are 15. See, 5 is an prime number, so divide 5 by the next prime number 5. So write 5 to the left of 5 and divide. 5 1s are 5. Again, 5 1s are 5. If we get all the quotient as 1, stop here. So the LCM of 12, 15 and 45 is equal to 2 multiply by 2 multiply by 3 multiply by 3 multiply by 5. Do the multiplication and the answer is 180. Let's solve one more question. Question number 2. Find the LCM of 20, 25 and 30 by common division method. First write 20, 25 and 30 in a line separated by commas. See, 20 and 30 are even numbers, so it is divisible by the smallest prime number 2. So write 2 to the left of the line and divide. 2 10s are 20. But 25 is not divisible by 2. So write 25 as it is. 2 15s are 30. Again, 10 is an even number, so it is divisible by 2. So write 2 to the left of the line and divide. 2 5s are 10, but 25 and 15 are not divisible by 2. So write 25 and 15 as it is. See, 5, 25 and 15 are odd numbers, so it is not divisible by 2. So take the next prime number 3, but 5 and 25 is not divisible by 3. So write 5 and 25 as it is, but 15 is divisible by 3. So divide. 3 5s are 15. Again, 5, 25 and 5 are odd numbers, so it is not divisible by 2, but it is not divisible by 3 also. So take the next prime number 5. So write 5 to the left of the line and divide. 5 1s are 5, 5 5s are 25 and 5 1s are 5. Again, 5 is an odd number, so it is divisible by the prime number 5. So divide. 5 1s are 5. If we get all the quotients as 1, stop here. So the LCM of 20, 25 and 30 is equal to 2 multiply by 2 multiply by 3 multiply by 5 multiply by 5. Do the multiplication. 2 2s are 4, 4 3s are 12, 12 5s are 60 and 65s are 300. So the answer is 300. Let's solve some examples. 3 Haryana roadways buses stop after 50, 100 and 125 km respectively. If they live together, then after how many kilometers will they stop together? Write the solution. First we will find the LCM of 50, 100 and 125 km. Everyone knows how we will find the LCM. So pause the video and find the LCM of 50, 100 and 125 and check. So the LCM of 50, 100 and 125 is equal to 2 multiplied by 2 multiplied by 5 multiplied by 5 multiplied by 5. Do the multiplication. 2 2s are 4, 4 5s are 20, 25s are 100 and 100 5s are 500. So the LCM is 500 km. Since if they live together, they will stop together after 500 km. Let's solve one more question. 4 bells toll at intervals of 8, 9, 12 and 15 minutes respectively. If they toll together at 3 p.m., when will they toll together next? Write the solution. First, we will find the LCM of 8, 9, 12 and 15 minutes. Everyone knows how we will find the LCM. So pause the video and find the LCM and check. So the LCM of 8, 9, 12 and 15 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 5. Do the multiplication. We get 360 minutes. See, the LCM is 360 minutes. But we have to find the answer in hours. So we convert 360 minutes into hours. We know that 60 minutes is equal to 1 hour. So 360 minutes is equal to divide 360 by 60. We get 6 hours. If the bells toll together last 3 p.m., then they will toll together next time at 9 p.m. because 3 p.m. plus 6 hours is equal to 9 p.m.